Now we will proceed with the next part of this subtopic, which is the trigonometric limits using this fact here. And this is very powerful when it comes to derivatives, alright? And actually I proved it in one of my previous video, which is using the squeeze theorem, or sometimes people like to call it the sandwich theorem. Okay, so I'm not going to prove it here. Okay, so if you're interested, you can go and watch my very early video. I think it's last year April. Alright, so in order to utilize this, there is something that you need to take a note of it, which is your angle inside the sine function and your denominator must be the same. If it is not the same, then you have to somehow make it the same. Alright, so it will be the same, it will still be equals to 1 if you flip it. Means if it is theta over sine theta, it will still be equals to 1. Okay, so let's start with the starter question again. So first question, yeah, is very simple. As you can see, the angle inside our sine function and our denominator are actually the same. So you just go ahead and write, we let theta be square root of 2x. Then what happened? Because your original question is x approach 0, so you have to check as x approach 0, then what happened to your theta? Also approach 0. Okay, you have to check, because it is not every time you will have very convenient case that your theta is approach 0. Okay, but in this case it is just very nice that your theta is approach 0. So you can write this as the limit as theta approach 0. Remember, if it is theta here, you have to write theta here, okay, over theta. And what is this? This is this theorem, isn't it? So it is equals to 1. Finish. Okay? Then what about the second one? Yeah, so this is the one that I want to talk about, which is if they are not the same, what happened? So in this case, we have sine kx over k over x, where k is a constant. So before you let theta equals to something, you need to make the angle and the denominator the same. So to do that, you know that you have to multiply by a k here, right? But you have to do it for both the numerator and denominator, so that it is actually multiplied by 1. So you need the k here. And maybe I think I should write it here, okay, so that it is clearer to see. Kx over kx. Okay, this kx is together. I multiply with a 1, which is actually k over k. Sorry, this one don't have k previously. So that now I take out the k, then I bring it outside, so that it is k times the limit when x approach 0 of kx over sine kx over kx. Okay, and now I can write my let theta be kx. Then as x approach 0, because your k is a constant, theta also approach 0. Hence, this will be k times the limit when theta approach 0 of sine theta over theta, which is k times 1, and it gives you a k. Clear? So it's about how you manipulate your function to utilize the theorem. Okay? So it's all about mathematical manipulation when it comes to these trigonometric limits. Alright? Let's do the exercises. Evaluate limits using this. Oh, by the way, previously I think I mentioned about L'Hopital's rule, right? You cannot use okay, actually if you are doing the question, you can use L'Hopital to evaluate. But if we are talking about proving this theorem, you cannot use L'Hopital's rule. If not, it will be a circular logic behind it. Okay, so just make a note of it. If people ask you to prove this, then cannot use L'Hopital's rule. Okay. let's do this. And actually, if you know how to differentiate this function, you can actually use L'Hopital's to check your answer. But in this case, actually, the instruction told you to use that theorem. So you just go ahead and use that theorem. So the first one is very easy. As I told you just now, we need to manipulate the function so that it will fit into our theorem. So in this case, I want to make the 4x to be 3x. How can I do that? I need to multiply with something, right? Which is 3 over 4. If I do that to the denominator, I have to do the same for numerator. And I can take out the 3 over 4, limit x approach 0, sine 3x. This and that will cancel, so it is 3x. Okay, and now what? You can use your let theta be 3x as x approach 0, theta approach 0. So it will be 3 over 4 limit theta approach 0 sine theta over theta, which is 3 over 4 times 1, which is 3 over 4. Finish. Very simple, isn't it? Just about how you manipulate your angle. Okay? Then the next one. Wait, yeah, oh, okay. Oh, sorry, these two are the same. Okay, sorry. Okay, the next one is this. Okay, so like I said earlier, it will be the same even though you flip, like the theta is on top, your sine theta is at the bottom. It will be the same. So again, this one is easier because you just go ahead and multiply by 3. But if you are doing this, then you have to be very careful, yeah, because now it is 1 over 3. And I took this question because it is a one-sided limit. Okay, then but then we'll deal with the one-sided later. 3x, okay, so 3x over sine 3x. Okay, then now what? You're approaching 0 from the left. One-sided limit from the left, we use what? H approach 0, C minus H, right? C minus H. Sine. Wait, I think we have quite a problem here. C, can we do that? C minus H. Oh, wow. Then, okay. So it will be 1 over 3, limit H approach 0, negative 3H, sine. I think we are missing out a 3 here, right? Yeah, we have a 3 here. Okay, negative 3H. Okay, yeah, very nice. We can use let theta be what? Negative 3H, right? As H approach 0, what happened to your theta? Also approach 0. So actually don't be scared by that negative. Actually doesn't matter. Okay, limit theta approach 0. Now it is theta over sine theta, which is 1 over 3 times 1 give you a 1 over 3. Okay, cool. We go to the next one. Okay, so it is not every time you have sine. Sometimes you have tangent, cosecant, cotangent, secant. Okay, so it's about how you manipulate it into the form that you want. So you know that you need the angle and your denominator to be the same. So before you convert into sine, what I would always do is I go ahead and make sure all the terms that I want to be the same. Okay, So I will just go ahead and multiply by 2 over 2, which is, okay, actually I can take out the 2, right? Limit x approach 0, tangent 2x over 2x. Okay? But I want sine. How can I get a sine of tangent? It is sine over cos, isn't it? So 2 limit x approach 0. If I take a sine 2x, then I have another cos, 1 over cos 2x, right? 1 over cos 2x, right? And actually, you know what? I don't have to worry about the cos at the denominator because cos 0 is equals to 1, which actually just 1 over 1 is a 1. You know that it's actually a 1 at the bottom. You actually 1 over at the back. So you actually don't have to worry about it. Now we can do our theta. Let theta be 2x. As x approach 0, theta approach 0. So it is 2 limit theta approach 0 sine theta over theta. And this one, because actually if you want to make it into theta also can. You want to remain as x also can. Okay, so I will just do theta since I already write the theta approach 0. Cos theta. So this part here will just be equals to 1, isn't it? So it is 2 times 1, and 1 over cos 0 is 1 over 1, which is 1, and the answer is 2. Alright? Cool? Next. Oh, okay, we have a cosecant and a cosine. And we have a 2x and 5x. But actually, it doesn't matter. Again, I told you, cos 5 times 0 is cos 0. Cos 0 is 1. We don't have to worry about it. The problem is, how do we get our sine? You know that cosecant is a friend of sine. Cosecant equals to 1 over sine. So, I will just go ahead and make this into x times 1 over sine 2x. Oh, very nice, very nice. Cos 5x. And you know what? I need a 2x, right? I just go ahead and multiply 2 and 2. This and that bring together is our 2x. So, 2x over sine 2x over cos 5x. Okay? Then, don't worry about the cos. You just go ahead and check your theta. Be 2x as theta approach 0. As x approach 0, your theta is also approaching 0, right? Then now, limit when theta approach 0. Okay, approach 0 of theta over sine theta. Okay, remember at the bottom, because I'm too lazy to convert my 5x to theta, so I will just leave the x. Okay, x approach 0 of cos 5x. And you know that it's equals to 1, so it doesn't matter. So equals to 1 over 1. Equals to 1? No, actually we make some instead, isn't it? We forgot about this 2. It should be a 2 here. It should be a 2 here. It should be a 2 here. So it's actually 1 over 2. Okay? So it's okay to make some mistake. Just you have to check your work after you're done with everything. Okay? So don't be scared by this cosecant and cos. Actually, if you can somehow write it in terms of sine, then you actually don't have to worry about your cos, very complicated 5x or whatever. Alright? Then next, we have a sine x as our theta this time. But actually, you know what? It is actually the same. Can actually directly do your theta equals to sine x. So as x approach 0, theta approach sine 0 is 0, isn't it? But it will be totally different story if it is cos. If this is cos, then as x approach 0, theta will approach 1. Then you cannot use this limit. Okay, so this is why we need to check. But in this case, it happens to be theta also approach 0. So yeah, just go ahead and do theta approach 0, sine theta over theta equals to 1. Finish. Okay? Last question. Okay, so this is a little bit complicated, but actually the direction is still the same. It's always the same when you see this kind of question. You just need to take out your sine, make the angle the same, and you are pretty much done. Okay, so I think we have a square, sine square at the bottom, which means it is sine 3x times sine 3x. Means I need a 3x, right? So I already got the x if I factor out from the numerator. Let's go and factor it out and see how it works. Approach 0, x1 minus cos x. And this fella here look very familiar, isn't it? Sine 3x times sine 3x. Just go ahead and separate this. But actually we don't need it. I was thinking about, what's that? The double angle. But actually we don't need it. But anyway, this will just be... Okay, you see how I do it here. X over sine 3x. I need 3x, so I multiply top and bottom by 3. This one I put together. Okay, so this one, okay, I use blue color. This one and this one done. Next, I want this one. I take this one. Okay, 1 over sine 3x. How do I make it into theta over sine theta? Multiply by 3x over 3x. And actually, I can see the answer already. Okay, let me write it like this. 3x over 3x. Actually, I can see the answer already. Okay, and last but not least, we have a 1 minus cos x at the bottom, at the back. Okay, so this will be, okay, let your, this one together is actually 3x already lah. Let your theta be 3x as x approach 0, theta approach 0. So just this time remember your constant, yeah? 1 over 3 limit theta approach 0 of theta over sine theta times this one limit, okay, limit when, okay, this one is actually wait, we have a problem here. We have a problem here, isn't it? If your x approach 0, means you have wait a minute. Okay, never mind. We just go ahead and do what we can do here. Theta over sine theta. And then we have a 1 over 3x. Okay, just this one. You know what I'm talking about? I'm talking about this 3x fella here. Because I want to make it in 3x over sine 3x. Oh, so I think we need the double angle so that we can cancel out with the x here. Okay, if not, you see what happened? You see what happened? So, okay, times your limit when theta approach 0 of 1 over theta, which is no good, right? Which is 1 over 0, which is something that we don't want. And in fact, it's actually okay, 1 over theta times limit when x approach 0, 1 minus cos x, which is no good. Okay, let's try, what's that? The double angle. And see how far we can go. Okay, so let me just get rid of all this. It's okay if we run through some trial and error, because not every time and always our first approach is not the answer, isn't it? Okay, so let me think about it. If we use the double angle, then we still have to factorize anyway. 1 minus cos x over sine 3x. I think this is correct. Sine 3x, then limit x approach 0. Okay, x over sine 3x. I still need a 3x here over a 3 over 3. Then this is 1 over sine 3x. I multiply with a 3x over 3x. And we know that this further here, 1 minus cos x is 2 sine square x over 2 by half angle formula, isn't it? Right? So it is, yeah, I think we are doing good. This times 2 sine square x over 2. Okay, you know what? I will just write it here so that, okay, 2 sine square x over 2. 2 sine square x over 2, which is what? Which is actually 2, okay, 2 times sine x over 2 times sine x over 2. Okay, the whole thing here is actually 1 minus cos x. Okay, and now what? Now I already settle this x over sine 3x. I also settle this sine 3x. Okay, and now let me take this. Okay, 2, I just bring it to the front, put it here. Then I have a sine x over 2. I just go ahead and multiply with x over 2, then x over 2 here. Okay, then it's actually, okay, let me write it more legible. Sine x over 2, okay, I multiply by x over 2 over x over 2. So that this I can later use the theorem, right? Okay, so I'm settled with this. And last but not least is again the same thing. Over 2, then multiply by x over 2 over x over 2. Okay. And now 2 limits x 3, this is actually 1 over 3 times 3x over sine 3x, then 3x over sine 3x. This is very nice. And remember this one I haven't settled. This one is sine x over 2 over x over 2. This one I haven't settled. Okay, well, I will settle all the yellow at one go. Okay, sine x over 2 over x over 2. You know why do we need it? Why do we need these two fella here? These two fella at the back here. It's because I want to bring the x on top. Okay, if your x is on top, there's no issue, isn't it? Because you are not dividing by 0. So now if we combine all three of them, okay, just write x over 2 times x over 2 over 3x. What happened? It is x squared over 4 over 3x. Right? So it is actually this and that can cancel. X over 12. Actually, you don't have to do the theta anyway, because you know that it is 0. The answer will be 0. Okay, let me shift this a little bit. Okay, like this. Or actually, the 1 over 3 I also bring it outside. 2 over 3. Then okay, so I hope you can understand how I manipulate this. Okay, and last but not least, multiply with x over 12. Okay, then we continue. Okay, we let theta be 3x. Then as x approach 0, theta approach 0. I do a little bit of shortcut here because I'm running out of space. So equals to 2 over 3 limit when theta approach 0 of theta over sine theta. Okay, then theta over sine theta. Then now for this part, I will let alpha be x over 2. So as x approach 0, alpha also approach 0. So it will be times the limit as alpha approach 0 of sine alpha over alpha, sine alpha over alpha, then the whole thing times the limit as x approach 0 of this value here, x over 12, which is, you know that this is actually 1, 1, 1, 1. 2 over 3 times 1 times 1 times 1 times 1 times. This is 0, which is 0. Finish. Oh, so this is actually a very interesting question because you need to manipulate, you need to make use of some identities so that you can utilize the formula. Okay, so yeah, this question is very, very nice. And I think it's from your worksheet. So yeah, that's it. That's all for today. And we are done with the trigonometric limits using this formula. Okay, so in the next class, we will talk about the commonly occurring limits and the limits to infinity of those transcendental function. Alright, so that's all for today. See you guys in the next class.